So next we're going to make the 3D drawing and we're going to really study what our molecule looks like in 3D. So we're going to start off by putting a carbon atom in the center. And then let's draw one hydrogen atom going straight up. And then we can put at least one other hydrogen atom in the plane that's bisected by this carbon and hydrogen. So a hydrogen, carbon, hydrogen, trio can all be bisected by the same plane. So those look like they're in this plane right here. Now, if I do that, I also have a hydrogen that's coming out at you and one that's going back into the page at me. So one is coming out of the plane of the page and one is going back in to the plane of the paper. If three atoms are bisected by, an imaginary plane or an imaginary paper, one will come out and one will go back. And we represent those with wedges and dashes. So a wedge hydrogen is going to represent the hydrogen coming out at me, and a dashed hydrogen is going to represent a hydrogen going back into the plane. And the bond angle is a known measured bond angle, but the idea here is that if we check out this bond angle, we see that it's got to be greater than 90 degrees. 90 degrees would be like right here. This bond angle is bigger than 90. It's not 180. It's somewhere in between. And so we know that we have a bond angle somewhere between 90 and 180. And it's the bond angle you get when you use the three-dimensional space to spread all four atoms out evenly in 3D space. It's actually 109.5. So it's a known measured bond angle. And then the name for this shape when we were learning shape names was the name for four things coming out evenly from the central atom. So four for tetra. It was tetrahedral. So that's an example of the first problem. What happens when you make a longer molecule, like say butane, for example? So I made a butane here in advance. I've got 4 carbons. So I connect all the carbons. And here's the thing. The molecules naturally like to make this zigzag structure. Well, first things first, I've got to put my 4 carbons and go ahead and count up all the hydrogens that you need. So I'll let you fill that in. And then I'll let you go ahead and draw your flat 2D drawing. And again, fill in with all the appropriate hydrogens here. So go ahead and I'll start you off and you can go ahead and fill that in. But what about the 3D drawing? We want to show this carbon backbone in its zigzag formation because that's really the most stable. So your carbon backbone ought to look something like this with the carbons in a zigzag formation. Okay. I might do a little better with pencil than I do at fitting this pen width in my box. But then what I wanted to point out was that, then each carbon has what looks like hydrogens wedging out of the plane of the page and dashing back into the plane of the page. So it's almost like there's hydrogens that are wedge and dash on each of these. So I just wanted to give you an idea of what does that look like. Well, if we draw them zigzag, the carbon chain all zigzaggy, then we have really a hydrogen wedge and dash, and then up here, same thing, wedge and dash. So that they're kind of coming out wedges and dashes. Now I haven't filled in all the hydrogens, so make sure that you go back and fill in with all of the hydrogens that you need in your structure so that every carbon has 4 bonds.